right, so we're going to head into our second lesson of the stoichiometry unit. We're going to calculate mass to mass calculations using the mole ratio. So this is the two-step problem. So it's not just moles to moles anymore. Obviously, yesterday was the most easiest part. But we're just adding a step. We're using mole to mole ratio to discuss mass now, not just moles. So we're going to be able to calculate number of grams produced or reacted for a substance given a chemical equation. So they're going to give us a chemical equation and a mass of something, and or maybe amount of moles, and we need to calculate the number of grams that's produced. That's it. So we're just learning one thing, so it's no big deal. There are 3 steps needed for these calculations, okay? So first, we need to convert grams to moles, okay? So we're given grams, we need to convert it to moles. We know how to do that, okay? We just use the molar mass of the known, so that's easy. And then we need to convert the moles of the known, okay? So what we know, and we've got moles, then we need to convert to the moles of the unknown. Okay, so that's what we did yesterday. So step 1, we did at the beginning of the school year. Step 2, we did yesterday. Step 3 is, again, stuff we learned at the beginning of the school year. It's basically step 1, but we're just converting out of moles to mass. Okay, so it's actually pretty easy, but some kids just kind of get stuck on this number 2 section, the converting moles to moles. So first practice question, what mass of silver chloride will react with 15 grams of aluminum? So yesterday we had a certain amount of moles, so we're just adding a step. We just got to convert this grams to moles first, then we got to convert out of moles, okay? So silver chloride will react, excuse me. So, okay, so we have aluminum, then we have silver chloride, okay? And that's going to yield, so this looks like a single replacement, doesn't it? So we're going to see if aluminum will react with, or will replace silver, and oh my gosh, it does. I'm so shocked. So we've got that. So I'm not going to make us discuss this, okay? You should know how to balance by now. So we're going to not waste our time remembering how to balance. Hopefully you guys got that. However, it's very common to see students, okay, when I'm grading tests, to kind of mess up on the balancing, even though we're all the way in stoichiometry and we've done balancing already a long time ago. And by a long time ago, I mean last unit, but still, okay? So, you know, maybe refresh your memory, but anyways, moving on. Now we're going to go to our mole calculation. So our known, okay, is whatever the problem gives us. It gives us 15 grams of aluminum. Okay, and our unknown is the question. What's it asking for? What's it asking for? What mass of silver chloride will react? So what mass? So question mark, mass, silver chloride. All right, so we're only looking at aluminum and silver chloride. We don't care about anything else, okay? However, we had to balance everything to know these first numbers, so sorry, there actually is a point to doing the second half. All right, so we're going to start off with our known like we always do, and then whatever's up here is always going to be here like it always is. And then we need to convert to moles, okay? So that first step was to convert to moles. Do you remember that? So if we're converting to moles, 1 mole needs to go on top. This is just a conversion, okay? So when we're given anything but moles, we must first convert 2 moles to do our mole to mole ratio. And then we need to get out of mole to moles, okay? So anyways, we've got this right here we got from the periodic table, and then this is how much every mole of aluminum will weigh, okay? So this is just conversion, that's why it's 1. It's not 1 because of this, okay? It's 1 because for every 1 mole of aluminum, it'll weigh this much. And we're doing this because we have a mass here, and we need to get to moles, so we can do our mole to mole ratio, so we can find out how many grams, okay? All right, so we canceled out our grams and now we're to moles. That's great, but we're not asking for moles of aluminum, are we? We're asking for grams of silver. So first we need to convert to moles of silver, then to grams. So next step is that mole to mole ratio. This 1 right here, okay, that is where we got this number from, okay? We got it from the coefficient. So if this would have been 2, we would have needed to put 2 here, okay? But it's 1, so we put 1 here, okay? And then the 3 came from this right here, all right? So this is the mole-to-mole ratio. This is our little bridge that gets us from aluminum to silver chloride. That's how we can switch from our elements, okay? And then, but moles of silver chloride is not what the question's asking, right? Grams. So we know how to convert moles to grams. We've been doing it since unit like 3 at 4, okay? So it's no big deal for us. So now we just need to cancel that out. So for every 1 mole of silver chloride, we need to find out how much it weighs, and that's what goes there. That's just a conversion, okay? So we get these numbers from the periodic table, and we just plug it in, okay? So this is the equation right here. So we must first go from grams of aluminum to moles, and that's what we did here. This is just a conversion, okay? So that means it'll always be 1 mole. We didn't get that from here, okay? This is a mole-to-mole ratio. You'll hear me say that. Mole-to-mole ratio is just using these coefficients, okay? And then here, this is another conversion, okay? We did not get this right here from here. If you thought we did, that's crazy because this is 3 and this is 1. But this right here just means for every 1 mole of silver chloride, you're going to have this many grams of it, okay? Then you just plug it into the calculator. You take 15 divided by this times this, and you push equal sign. And you should get your answer, okay? So that's no big deal. Just that extra mole-to-mole ratio step, that's new to us. All right, so next question, what mass of oxygen gas would be produced from the decomposition of this many grams of lithium chlorate? So we know that we have lithium chlorate, okay? And then when we decompose lithium chlorate, we have something chloride plus oxygen, right? Okay, so we'll have lithium chloride plus oxygen. And then we need to balance it, but I think I've already done it for you, okay? So make sure you know how to balance. If you don't, that's something you need to practice, but I'm not going to make you practice when you're learning new things. So our known is what's in the question. So 37.2 grams, that's what I got here. 37.2 grams of lithium chlorate, that's what I did with it, okay? Our unknown is what the question's asking. What mass of oxygen? That's it, mass of oxygen. So when we actually do our calculations or set up our equation, the known always goes first, okay? That's the same. Sorry, we're only looking at this one and oxygen gas. We don't care about this. All right, so here's our known, okay? So whatever unit goes here must go here. We need to convert from grams to moles, so we can do our mole-to-mole ratio. And then we can convert from moles to whatever unit we need, which it looks like we need grams of oxygen, okay? So we need to find out how much lithium chlorate weighs, which is right here. I did it. Okay. So lithium chlorate weighs this much. We just found these numbers on the periodic table. We've done this since Unit 2. And then that's how much every 1 mole of lithium chlorate weighs, okay? This is not gotten from here, okay? This is just a conversion. We use these numbers in the next step, okay? So the next step, we have the mole-to-mole ratio, okay? So the moles of lithium chlorate would go at the bottom, okay? So we can cancel this out because we need moles of oxygen in order to move on to the next step. So we get our numbers from the coefficients in the equation, okay? And then our moles of lithium chlorate cancel, and we're left with the moles of our desired element. Now, the unknown isn't how many moles of oxygen, right? We need how many grams of oxygen. So we need to cancel out our moles of oxygen, okay? This is a conversion now. That means we're not getting this from a coefficient up here. We just know that for every 1 mole of oxygen, it's going to weigh 32 grams, okay? And don't forget this 32 includes 2 oxygens, which are about 16 grams each per mole. So for 1 mole of oxygen gas, which has 2 oxygens, it's going to weigh 32 grams. And then the moles will cancel out, and we will have our answer. All right, so important points, okay? So you are calculating the mass for 2 different substances, okay? You have one on one side of the mole-to-mole ratio and one on the other, okay? We know how to do those from the beginning of the year. Molar mass always equals to 1 mole. That's the conversion. It's not the mole-to-mole ratio. And the only time you use the number of moles, like the coefficients in the chemical reaction, is when you have, sorry, my battery's dying, is when you are doing the mole ratio step, so that step in the middle. All right, let's go over a homework problem for mass-to-mass calculations. And we're going to do number 5 on your homework. Just remember, all homework is posted on line, so the answers. So I think I have shown all of my work. I'm not sure. I can't remember. But all work is posted online if you want it to have access to it. Okay, so the question says, if 11.5 grams of chlorine reacts with aluminum, how many grams of aluminum chloride would be formed according to the following reaction? So the cool thing is, in the homework, you actually don't have to create your word equation, formula equation, and balance it and whatever. It's all balanced here for you, so that's nice. So now all we have to do is the stoichiometry problem. So our known, okay, our known is this, 11.5 grams of chlorine. The unknown, okay, how many grams of aluminum chloride? So that's our unknown. How many grams of aluminum chloride? Okay. So we just set up our problem now. So every time we do this, we need to start with our known, okay? So also, I'm going to circle what I'm using. So I'm going to be using these. I don't really care about aluminum. Yeah, I don't care about aluminum. And we write our known first. So the known is 11.5 grams of chlorine, okay? Will react with, I'm sorry, no, we don't care about that. So grams of chlorine go down here, and we are not in grams, I'm sorry, we're not in moles, so we need to convert to moles. So moles of chlorine, and this is a conversion, so that's how we know we need the 1, okay? And then for every 1 mole of chlorine, chlorine gas, sorry, chlorine, okay? So for every 1 mole of chlorine, that's important because we actually have to multiply this mass by 2. So chlorine is 35.453, okay? So that means 35.453 times 2, because there's 2 of them. So the mass will be 70.906. Okay? So we've converted it to moles, okay? Now we are needing to jump from chlorine to aluminum chloride. So we need to jump from moles of chlorine gas to moles of aluminum chloride, okay? And then this is a conversion. This is mole-to-mole ratio. Mole-to-mole ratio, that's when we're using these numbers right here, okay? So mole-to-mole ratio, moles of aluminum chloride, there's 2 here. Moles of chlorine, there's 3 here, okay? So we've converted. So now we've gotten rid of grams of chlorine. We've gotten rid of moles of chlorine. We're actually now in moles of aluminum chloride. So our question's not asking for moles of aluminum chloride. It's asking for mass or grams of aluminum chloride. So we need to get rid of the moles of aluminum chloride. Okay, and this is a conversion, so we're going to use 1 here, okay? And we need to find out how much aluminum chloride weighs. So aluminum, 26.982 plus chloride with 3 chlorine, sorry, which is chlorine is 35.453. 35.453. If you do it the way I do it, make sure you have the parentheses there, times 3, close parentheses. So the molar mass is 133.341. Grams of AlCl3. Okay, and that's our desired unit. Okay, we're at grams of aluminum chloride. So we just need to plug this in the calculator and we're done. Okay, so in the calculator, we're going to do 11.5 divided by 70.906 times 2 divided by 3 times 133.341 equals. So the answer is 14.417. 14.417. Let's look at here to look at our significant figures. There's 1, 2, 3 significant figures here. 1, 2, 3, it needs to be cut off here. And 1 won't round it up. So the answer is 14.4 grams of aluminum chloride, because the moles canceled. Okay.